We start from the simplest types to the most complex ones, so watch the entire tutorial carefully. There are two categories of TypeScript types: built-in types and user-defined types. Let's begin with the built-in data types. The most basic data type is the simplest true-false value, which JavaScript and TypeScript call a boolean value, as well as all programming languages. This is how we explicitly define a type. TypeScript can infer the type based on the value of the expression on the right side. Typeof is used to find out the type, in this case boolean. Numbers can store integers, float, hex like the blue color. Notice the prefix 0x, binary 0b, and octal with the prefix 0o. String. There is not much to say, it is the same as in most programming languages. Date. There are several ways to define a date, but one of them is using the new date, which creates a new date object with the current date and time. To work with dates, most of the time you need a library, a very intuitive and good one being Nodejs. I'm not affiliated with them, but the library is really great. The link is in the description. Arrays. There are two ways to declare an array as in the example on the screen. Void. The void type is most often used when a function does not return a result. The print full name function displays the result in the console, but does not return anything. There is no need to type void explicitly because TypeScript will infer it. The function takes one parameter, the string full name. Never. Function returning never must have an unreachable endpoint. This function will never return a result. There is also the case where it is an infinite loop, then again it will not reach the end of the function. Null and undefined. JavaScript has two primitive values used to sign null absent or an initialized value, null and undefined. TypeScript has the corresponding types by the same names. Undefined, when something hasn't been initialized, not assigned a value, use undefined. And null, when something is currently unavailable. Null is assigned to a variable to specify that it doesn't contain any value or is empty. As you can see, undefined, null and false are evaluated as hello string, and in the last lines the first operand will be displayed. If the string str is undefined, null or false, the instructions on the first branch will be executed, otherwise on the second. So you don't need to write explicitly if str equals undefined, null or false. This is a very common and important use case. Let's look at some more detailed examples. If you still want to test a certain value, keep in mind that the equality operator checks the values. So undefined is equal to null, and the one of strict equality checks the value and the type, so undefined is not the same as null. Nullish coalescing. The nullish coalescing operator is a logical operator that returns its right-hand side operand when its left-hand side operand is null or undefined, and otherwise returns its left-hand side operand. Learn very well the difference between nullish operator and logical OR. Nullish operator returns the operand on the right side of the expression only when the value on the left is null or undefined, and logical OR when on the left is any false value. Unknown. We may need to describe the type of variables that we do not know when we are writing an application. These values may come from dynamic content, for example, from the user, or we may want to intentionally accept all values in our API. In these cases, we want to provide a type that tells the compiler and future readers that this variable could be anything, so we give it the unknown type. We can narrow it to something more specific by doing typeof checks. In this example, even if 10.123 is transformed and displayed in 10.1, TypeScript signals an error because it does not know the type. We can help it by testing the type, and now TypeScript clearly knows that not sure stores a number and executes the instructions. In some situations, not all type information is available or its declaration would take an inappropriate amount of effort. This may occur for values from code that has been written without TypeScript or a third-party library. In these cases, we might want to opt out of type checking. To do so, we label these values with the anytype. The anytype is a powerful way to work with existing JavaScript, allowing you to gradually opt in and opt out of type checking during compilation. Unlike unknown, variables of type any allow you to access arbitrary properties, even ones that don't exist. These properties include functions, and TypeScript will not check their existence or type. As an advice, try to avoid using the anytype. Using anytype, the TypeScript loses its value. Any should be used only in very special cases. Object. As you can see, we cannot assign a false value, a string, or a number to an object. Assignability table. The following table summarizes assignability between some abstract types. Rows indicate what each is assignable to, columns indicate what is assignable to them. A checkmark indicates a combination that is compatible only when strict null checks is off. The unknown is assignable to any, but it's not assignable to the others, and so on. Now we turn our attention to user-defined types. Enums. Enums are a feature added to JavaScript by TypeScript, which allows for describing a value that could be one of a set of possible named constants. Unlike most TypeScript features, this is not a type-level addition to JavaScript, but something added to the language and runtime. An enum can be defined in two ways. In the first version, when we access the baking value, the index is returned, and in the second one, the value that we set explicitly. Tuple. A tuple is another sort of array type that knows exactly how many elements it contains and exactly which types it contains at specific positions. The tuple person contains two values, the first being a string and the second a number. They can be anything. In this example, the first value is the name and the second is the height. Not too intuitive. But to solve this problem, we enter the more advanced chapter of the objects. Interface. I created a new type of data called iPoint, which stores the coordinates of a point. I personally use the prefix I for interfaces, but it is not necessary. It is simply a convention to immediately realize that it is an interface. Type. The second option is to define a type alias using the type keyword. Class. The third option is to define a class. Okay, and now you will say, why are there three options to define this type of data, the difference being only the keyword? Because it's not the only difference. Let's find out which are the others. We created a new type, the IPerson interface, that defines the shape of an object with the only name property, which is a string. Now we want to define a new iEmployee type that will have the name and starting date fields. We already have the IPerson data type, so all we have to do is to extend it. For this, we have to use the extends keyword followed by the base interface. A type can be extended by making an intersection with the ampersand operator between the person type and an object that has the starting date field. Union type. We definitely need an ID that can be a string or number. This new type is called union type. So, the two employee type objects are perfectly valid. Of course, you choose either string or number for an ID, but this is for presentation only. In this example, we can extend the iColor interface by taking the hex field from color. Also, the question mark is used to indicate that the label is optional, so white with the undefined label is valid. Pick color hex will return a data type that represents a single field object with hex property taken from color. Pick is one of the utility types. The list contains partial, required, read-only, record, omit, exclude, extract, and others. If you want a tutorial on these utility types, leave a comment, and if more of you want, I will make one. Also, always check the description because there may be news that I will publish there and also related tutorials. Let's continue. Add new properties. We can add a brightness field by declaring the iColor interface once again, so iColor will have three fields. The previous two merged with the brightness field, but a type once created with the type keyword can no longer be redeclared. A class can implement an interface, but cannot implement a type. An object defined by a class can be created using the new operator and calling the constructor with necessary parameters. This keyword is used to reference the current object. Classes are a very big topic, so it is the subject of another tutorial. Generics. A major part of software engineering is building components that not only have well-defined and consistent APIs, but are also reusable. Components that are capable of working on the data of today as well as the data of tomorrow will give you the most flexible capabilities for building up large software systems. In languages like C# and Java, one of the main tools in the toolbox for creating reusable components is generics. That is, being able to create a component that can work over a variety of types rather than a single one. This allows users to consume the components and use their own types. Let's say we define a magic box that can contain a string, another box contains a number, another a boolean, and so on. In order not to write new data types, we can create a generic one, whose data type that will be contained in the contents field will be specified on call. Literals. Two methods to transform the object into a literal object using as. If you hover on HTTP request method or HTTP request method 2, you'll notice that the type is get, not a string, as const makes all the fields read-only. If you are wondering what is the best way to define a new type of data, well, there is no clear answer because it all depends on the application you are building and what you want to achieve. From experience and from several libraries, it is recommended to use interfaces for objects and types for functions. Props from React components should be defined as interfaces instead of types, but again, that's not a rule. Will you use TypeScript in your projects? Write the answer in the comment section. I invite you to subscribe, like and share to learn programming fast. Activate notifications by clicking on the bell. Thanks for watching!